My humble self, Mr. Daramola AP, your mathematics teacher. Right, our class rules remain the same, okay, and the quote of the day remain the same. If people do not believe that mathematics is simple, it is only because they do not realize how complicated life is, by Plato. And the topic before us today is area and perimeter of circle and semicircle, rhombus and kite. Alright, let's look at this. Chop it up a bit. This is a circle being divided into 4 quadrants. And rearrange the part. This is what you will have. Now, when you chop it into smaller sectors, we have this, and it has been arranged in part again, as it is starting to look like something else. Even smaller sectors becomes this, and it's near enough to a rectangle for me, as you can see. Then what do we have? That means a circle can be translated into a rectangle. Is that not beautiful? Yes, it is. What's the length and width? The width is the radius of the original circle, and the length is half the circumference. Recall, the circumference of a circle is pi d or 2 pi r. So then half the circumference we have pi r, because r is diameter divided by 2. So we have approximately a rectangle. And recall, the area of a rectangle is length times breadth. So that means the area of a circle is radius multiplying pi times radius. And that will give us pi r squared. That is how the area of a circle is pi r squared. Good. Let's move on. This is a football pitch, and a final return to our little football pitch. The radius is 10 yards. So the area is pi times 10 times 10. Remember, pi is 22 divided by 7, or 3.14. Or sometimes we use 3.142. When you multiply out, you have 314 square yards. Area and perimeter of semicircle. This is a semicircle when you divide the circle into 2 equal parts. So the area is area of a circle divided by 2. And when you are looking for the radius, it is the square root of 2 times the area divided by pi. And the perimeter of a semicircle is the distance around this shape. For the curved part, it is pi r. Alright? Because you divide 2 pi r divided by 2. Then you now add the diameter to it. So it is pi r plus d, or pi d plus 2. Okay. Area of rhombus. And the area of a rhombus is this multiplication or the product of the 2 diagonals divided by 2. And the perimeter is 4l. The side of the square and the side of a rhombus are both equal. So the perimeter of a square and a rhombus are the same. This is a question. A rhombus of diagonal 12 cm and 16 cm was drawn by a scholar. What is the area? We have this as the area. 12 times 16 divided by 2, which is 6 times 16, which is 96 cm squared. Area of a kite. This is a kite with base B, the smaller part of the kite height A, height 1, then the other one height 2. So the area is half times the base plus the height of the entire kite. So you sum up the height 1, height 2, you multiply it by the base, you divide the answer by 2. Remember, perimeter is distance round a shape. And before you can find the perimeter of a kite, you need the knowledge of Pythagoras theorem. But we are not doing that now. Example, calculate the area of a kite with base 12 cm and height 4 cm, and calculate the area of a kite with base 12 cm and the two heights 4 cm and 8 cm. And the solution, we have it there. The base is 12, the two heights are 4 and 8. So you sum up 4 and 8, you multiply by 12, you divide by 2. We have 72 centimeters squared. Relax and let us take a look at this video.
What is the area of a kite? Well, all you know is the length of each of those diagonals. Well, let's go back to what we do. We know that the area of a rectangle, so if I write in some right angles, maybe this is parallel, we know that this area is going to be equal to its base times its corresponding height. So is there any way that we can take this height and rearrange its pieces to make a rectangle? Well, let's start off by what we know. We know that the diagonals in a kite are perpendicular. So what I'm going to do is I'm going to cut out this piece right here out of the whiteboard, and I'm going to translate it until it fits into this area right here. I'm going to do the same thing with this piece, except, and actually, by translate, I'm going to translate and then rotate. So I'm going to do the same thing with this piece right here. I'm going to translate and rotate. So I'm going to redraw my kite, where we have our initial piece, which is right here, and we have this bottom piece right here. But then I said I translated and rotated. So now we have this other piece here that we cut out, and up here we have another piece that we cut out, translated, and rotated. So let's start by saying, well, what do we know? We know that this distance right here is the distance of diagonal 1. So I'm going to label it as D1. What else do we know about the diagonals of a kite? Well, I know that this D2 is bisected by the other diagonal, which means this piece right here is going to be D2 divided in half. So now we've created, since these are all right angles, we have created a rectangle. And we know the area of a rectangle is the base times the corresponding height. So the area of this rectangle, our base is D2 divided by 2 times our height, which is D1. So another way of writing this is to realize that D2 and D1 are in your numerator. So you just rearrange it and write it as D2 times D1 divided by 2. Key thing to realizing this formula was cutting out these pieces, rotating and translating, and saying that the diagonals of a kite, that this diagonal is bisected by the other diagonal. But this also has to apply to a rhombus. So there's going to be two ways for you to calculate the area of a rhombus. The first way is to say, if you know a height and a corresponding base, then you can just calculate the area as base times height, because a rhombus is a parallelogram. The other way is to say, well, the diagonals of a rhombus are also perpendicular, and they bisect each other. So this formula of D1 times D2 divided by 2 has to apply. So you've got a couple options when you're trying to calculate the area of a rhombus. You can use a height and base, or you can use D1 times D2 divided by 2.
Alright, scholars, I believe you all have a good understanding of the video. Okay, the plenary for today, I believe we all can now find area of a circle, which is pi r squared. Perimeter of a circle as 2 pi r or pi d. Area of a semicircle as pi r squared over 2, and perimeter of a circle of a semicircle as pi r plus d. area of a rhombus as d1 times d2 over 2, and area of a kite as half times the base with the sum of the height multiplying. Okay, what's next? We've been able to learn something, and in our next class we'll be learning about transformation of two-dimensional shapes. The topic is prepared by Mr. Daramola, Oxford Mano College, reference to YouTube and text. Thank you.